In this problem, we're asked to graph a rational function by first finding the equations of the horizontal and vertical asymptotes. To find the equation of the horizontal asymptote, you should compare the degrees of the numerator and denominator. In this rational function, both numerator and denominator have degree 1, so they have same degree in numerator and denominator. When that is the case, then the horizontal asymptote is equal to the ratio of the leading coefficients. So in this case, the horizontal asymptote has the equation y equals, so ratio of the leading coefficients. The leading coefficient is 3 in the numerator, 1 in the denominator. So y equals 3 is the equation of the horizontal asymptote. To find the equation of any vertical asymptotes, you should first reduce the rational expression and then set the denominator equal to 0. In this case, we would have x minus 2 equals 0, so x equals 2. This is the equation of the vertical asymptote. So to begin graphing, I might go ahead and sketch those asymptotes as dotted lines. So here's the vertical asymptote at x equals 2, and the horizontal asymptote at y equals 3. And the scale on this grid might not be perfect for the function we are given, but we'll do the best we can here. Now to fill in the graph of the function, we should now substitute various x values to determine where the graph lies. So for example, to the left of this vertical asymptote at x equals 2, we should substitute some value of x less than 2 to determine if the curve lies like this below the horizontal asymptote at y equals 3 or like this above the horizontal asymptote at y equals 3. The y-intercept might give us a good clue, or will give us a good clue about where that graph lies. So I'm going to go ahead and find the intercepts for this graph also. To find the y-intercept, we should plug 0 into the function. Let x equal 0 to find the y-intercept. And so this gives us 3 times 0 plus 3 over 0 minus 2. So negative 3/2 is the y-intercept. So I could go over here to the y-axis and plot a point at negative 3/2. So that's negative 1.5 there. While we're at it, we could also find any x-intercepts. So you find the x-intercepts by setting the y value, the f of x, equal to 0. So that's 3x plus 3 over x minus 2. But for a rational function, you always end up with just the numerator equal to 0, because the first step in solving this equation will be to multiply both sides by the denominator to clear that denominator, and you end up with 0 equals the numerator there, 3x plus 3. If you solve that equation, you end up with x equals negative 1. You subtract 3 from both sides and then divide by positive 3, and you wind up with x equals negative 1. So we have an intercept on the x-axis at negative 1, and that's the only place where the graph touches the x-axis. That information is also useful in drawing the graph. So also knowing the basic shape of these rational functions, these graphs of rational functions, we could fill in the curve here, going through those 2 points and approaching the horizontal asymptote on the far left end of the graph, and approaching the vertical. Remember that when the graph approaches the vertical asymptote, it will either dive down to negative infinity or go up to positive infinity. But since there's no x-intercept over here, we know that the graph must dive down to negative infinity. Now we just need to determine where the graph lies over here on the right. And I'm going to argue that we already know that the curve should appear up here above the horizontal asymptote. The reason is if the graph were below the horizontal asymptote, there would be another x-intercept, and we would have found it in this step when we set the function equal to 0. But just to be sure, you can always plug in an x value, something beyond that vertical asymptote at x equals 2, so something like x equals 3 or x equals 4. I'll go ahead and evaluate f of 4 to determine where that y value lies. So if x is 4, I have 3 times 4, so 12 plus 3 in the numerator. There. And then 4 minus 2 in the denominator. So that gives me 15 over, so I'm running out of room here. 15 over 2, so 7.5 for our y coordinate, which is up. It's out of the region that I have here on my grid. But the main point is that it lies up above the horizontal asymptote at y equals 3, and so the graph will lie up here. I'm just going to sketch it in there.